And welcome to IB Pre-Cal without Ms. Getz. Boo! Please get your warm-up books, copy down your homework, and think about these problems. These problems are from AAF. We're starting our trig unit, one of our many trig units actually. So you're going to have to remember some of the prerequisite knowledge from unit, what was it, unit 8, I think, of AAF. So Paul, you can pause for a minute and see if you remember how to do these problems. Some of these problems, remember, you're going to not have a calculator to do this. You need to convert from radians to degrees. So remember, some of your special angles you need to have at the forefront of your brain, and one of those special angles is pi over 4, and hopefully you remember that pi over 4 is 45 degrees, and you've got 5 of them. So 5 times 45 is your degree measurement. Five times 45 is 225, yes? And remember, if you think about your unit circle, here's pi over 4, right here. That's 1 pi over 4. Here's 2 pi over 4. Here's 3 pi over 4. Here's 4 pi over 4, or pi. And here's 5 pi over 4. Right? Or 5 times 45. Now 3 does not correspond with any of my specials. Remember, my specials are whole numbers of pi, pi over 2's, pi over 3's, pi over 4's, and pi over 6's. This is neither, right? It is none of those specials. Now remember, radians are unitless because they are a ratio. So there's no mark on here. That's how I know it's radians. So to convert to degrees, I need to use the ratio that the whole circle in, right, the whole circle, in radians is 2 pi times r, but our unit circle has a radius of 1. Or in degrees, it's 360 degrees. So of course I can reduce this to pi over 180 degrees. But I can just as easily make the ratio of the whole circle and say the whole circle in degrees is 360, or 2 pi radians with a radius again of 1, and that reduces to 180 degrees over pi. Which one of these ratios I use depends on if I'm going, what I want to get rid of. Technically, this is 3 radians, and I want to go to degrees, so I want to use this formula because it's going to keep the degrees in it. So 180 degrees over pi, and I get 540 degrees divided by 3-ish. Okay, and you can either leave it like that, or you can get your calculator out and say that it's somewhere, well, remember, pi is 3 and a little bit, right? So 540 divided by 3 and a little bit, right, is whatever your calculator says. I don't have my calculator with me right now. But if I want to convert from degrees to radians, again, I'm looking for my specials. 330 degrees is a special. 330 degrees is right there with 30 degrees left over, right, to get back up. So 30 degrees, I know, goes with a pi over 6. right? It's a sixth of pi, so how many pi over 6s did it take to get around there? 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. Would have been probably easier for me to think of going backwards and realizing that all the way around in sixth, right, is 12 pi over 6, and I just needed to go 1 pi over 6 less. Right? That would have been a little bit faster than all my tick marks. 220 is not special, right? Special, pi over 4, special, not special, not special. So I have to use my formula. Now again, this time I'm going to radians, so I want degrees to cancel out. So which one of these formulas should I use? 1 or 2? Since I want degrees to cancel out, you want 180 degrees on the bottom, right? Because degrees divided by degrees cancels out, right? These zeros are going to cancel out. 2 goes into 18 9 times and into 22 11 times. So I end up with 11 pi over 9 radians. All right, so the things you have to make sure that you remember: how to convert if it's not special. Now, of course, you can use these formulas. Right? This is when I want to go 2 radians, and this is when I want to go 2 degrees. You can use them, but trust me, it is going to be in your best interest to remember your specials. And your specials are, again, are multiples of whole pi's, pi over 2's, pi over 3's, pi over 4's, and poor pi over 5 is left out, and pi over 6's. Right? That corresponds to 100 multiples of 180, multiples of 90, multiples of 60, multiples of 30, 45, and 30 degrees. Now, in math and in calculus and further math, we really don't use degrees very much. We use it more in trig than we do anywhere else. Physics uses degrees a lot, and so does navigation. Oh, look at that! How bizarre! This gas station has a sign on it saying that Unit 4 is Trigonometric Functions. Who would have thunk? Woot! So, beginning of this unit, angles and their measures. There's really a lot more to this sound. This sounds so innocuous, and you won't have too much trouble. This topic is a topic for your IB exams. You will not need degrees, minutes, and seconds in AP Calculus. You won't even need it in physics. You need degrees, but not the minutes and seconds. You definitely need to know how to go back and forth between degrees and radians. Arc length and linear speed are your two newer topics. So just some review: degrees and radians. The central angle of 1 radian intercepts an arc length of 1 radius. So from geometry, a circle, darn it. A circle central angle is measured from the center. The central angle is the same as the arc it intercepts on the circumference of the circle. So here's a better drawing. But if I have a central angle of 1 radian, I can say that the arc length then is equal to 1 radius. It sounds kind of funny, doesn't it? The reason is there are 2 pi radians in a full circle of a radius 1, right? Or pi radians in a straight angle, which of course is 180 degrees, right? Pi halfway around a circle is 180 degrees. Pi is in radians, 180 is in degrees. 2 pi radians in a full circle with a radius equal to 1. That's our unit circle. So here's a cute little applet. Shows a circle with a radius. If you take that radius outside the circle and bend it to the circumference, there's your central angle. So 1 radian, right? There's 2 radians, 3 radians, and a little bit, pi. Then of course I can go 3 and a little bit more and get 2 pi all the way around my circumference with a radius of 1. And again, that's just 1 unit, right? The radius is 1 unit. So suppose I had a circle that was 10, right? Let's say that radius was 10 miles. I still can say that is really 1 unit, right? So no matter the size of my circle. So again, watch, if I have the central angle is 1 radian, that's equal to the arc, and there's 3 and a little bit arcs around half a circle with a radius of 1. That's pi. All the way around, 2 pi times 1. Right? So circumference, and an arc is a piece of the circumference. So again, degrees, minutes, seconds. Only doing this because IB makes me. I don't really like it. So, degrees to radians, important. Degrees, minutes, and seconds to radians, meh. Nevertheless, you do need to know that minutes are defined in terms of degrees. 60 minutes is equal to 1 degree. 60 seconds is equal to 1 minute. Notice those units don't quite match up, right? I have degrees, and then I can convert minutes to degrees, and I can convert seconds to minutes and vice versa. So what if I want to convert 37.425 degrees to degrees, medians, and seconds? So here's what we need to do. And if you already know how to do that, well then certainly pause and see if you get the same answer as me. Well, this is 37 degrees, so that's all good. Plus this part of a degree. Well, that part, if this is the degrees, maybe I can take this into minutes, right? How do I take that part into minutes? 60 minutes is to 1 degree, as 0.425 degrees is to how many minutes? So again, what's going to happen is these degrees are going to cancel out, and I'm going to be left with 37 degrees plus, and this is, I got my calculator out, and I got 25.5 minutes. So here I have degrees, and now I got my minutes. But I also want seconds. So now I have to break this up and say, well, if I have 25.5 minutes, that's the same as saying I have 37 degrees plus 25 minutes plus 0.5 minutes. Degrees, minutes. I want this to be seconds. So to convert the minutes to seconds, I have to do 60 seconds is to 1 minute. And then my minutes cancel out, and I get 37 degrees and 25 minutes and 30 seconds, which is usually written as without the plus signs. Good. Let's go the other way. Convert to radians. So converting to radians, I need to break this back up and say, well, you're at 42 degrees and 24 minutes and 36 seconds. But I want to go to degrees. I'm sorry, I want to go to radians. Well, the 42 I can convert, right? But I've got these other weird things. So the first thing I need to do, go to all degrees. So go backwards, right? I need to convert, this 42 is already in degrees, but this is in minutes and I want to go to degrees. So to go to degrees, I'm going to multiply this by something over minutes, right? 1 degree is 60 minutes. And if you do that multiplication, I get 0.4 degrees. And I already have 42 degrees. Now the question is, how do I get from seconds back to degrees? If I look up here, I can take seconds into minutes, right? So in order to cancel out the seconds, 60 goes here, and 1 what goes here? Minute. So I can cancel out the seconds, but now I have 36 over 60, or 1/2 minutes. How do I get to degrees if I'm in minutes? I want to cancel out the minutes, so I'm going to have 60 minutes down here with 1 degree. And now my minutes will cancel out, and I'll be left with 36 over 60 squared, but my units will be degrees. Adding that all together, I get 42.41 degrees. So I'm in all degrees, but what do I need to do next? Convert to radians. And how do I want to convert to radians? I want to multiply by something where I'll get the degrees to cancel out. I want degrees to cancel out, so what ratio do I have? On a circle, pi is the same as 180 degrees. Cancel, cancel. So I have 42.41 times 3-ish, oops, divided by 180. I used my calculator. Check to make sure I did this right because I just wrote it down. 0.74. And again, my units are radians, but that's unitless, right? So there's no mark on them. So one of your homework problems, some of your homework problems at the very beginning ask you to do this straight up conversion, but then you also have a problem later on in your homework problem that refers to a compass. And it talks about like what kind of, you know, what is, what degree measurement would go with northeast, per se, let's say. So you need to know that for a compass, when we're talking about degrees, north is 0 degrees, which is kind of weird, right? North is 0 degrees. So when you measure this way around the circle. So northeast would be right here. Well, from north, which is 0 degrees, how many degrees is that? 45 degrees. So you have some problems like that, which it just takes orienting yourself with 0 degrees as north and going clockwise, being in a positive rotational direction, which is kind of counterintuitive to how we usually deal with measurements around a circle. All right. Now I need to go and talk, our next objective is circular arc length. So this is what's weird about arc length is it's circular. So you're used to seeing a shape, for instance, like a rectangle, and if I ask you what is the perimeter of this rectangle, well, you add the sides. So let's say that's 5 plus 2 plus 5 plus 2. Right? So the perimeter is 14 units. Linear units, right? Not squared. But if I want to know about a circle and I want to know about arc length, well, I know what the circumference is, the circumference all the way around. I know the circumference all the way around is 2 pi r. But what if I only go that far? If I only go this far around the circle? What is this arc length? Arc length in our books is called S. So here is a formula for arc length. Arc length is the radius times how much you travel, right? All around the circumference, which is theta. And if you remember from AAF, I always made you, when you drew your angle in radians, I made you trace along the outside, and this is one of the reasons why. I wanted you to make sure that you got into your head that what you were doing was measuring a piece of the circumference. Because the central angle is equal to the arc it intercepts, when you are in radians and you travel around the circle here, this length, arc length, right? This length is the same as theta if you're on the unit circle where radius was equal to 1. So if you aren't on a unit circle, you just have to multiply by the radius of your circle. You do, though, have to be in radians. So to find the arc length of a circle with radius 10, notice units inches and a central angle in 10 radians, well, that's no big thing, right? As long as I know my formula for a piece of the circle, the arc length is equal to the radius times the central angle in radians, but remember radians are unitless. My arc length is 100 inches, which is linear, right? This is a linear measure. So it's as if you took the circumference and straightened it out, right? Straightened it out and measured it, you would get 100, cut it, measured it straight, you would get 100 inches. But what if I ask you to find the radius of a 1-foot arc with a central angle of 20 what? 20 degrees. I can't go straight to my formula. I mean, my formula is arc length is equal to the radius of the circle times the central angle in radians. So first I have to realize that they've given me 1, which is the arc length. They're asking me to find theta. I'm sorry, they're asking me to find the radius, but theta is 20 degrees. How do I get rid of degrees? Well, 180 degrees on the circle is the same as pi. Cancel, cancel. So 1 is equal to, and this 0 will cancel with this 0, this 2 will make a 9, right? So what do I have here? Oh, that looks so sloppy. So what do I have over here? I have pi over 9, r. So to get r by itself, 9 divided by 3-ish, which should be a little bit smaller than 2. Check me on your calculator. I think it's 2.86. Hey, what are your units? Right? This was 1 foot. So remember, once I've converted to radians, this is unitless. 9 over pi is unitless. So I still have my times 1 feet here. How about this one? Let me erase. Oops, sorry. Find the perimeter of the region R pictured to the right. So here's R. So it's this whole region, which used to be a circle. But part of it got cut out. Perimeter is the length, right? It's a linear unit. So I want to know the length of this circle if I were able to lay it out straight and measure it. Right? So that length is the entire circle, 2 pi times the radius of what? Minus something. What is it minus? Right? It's minus that little arc. So how do I find this length? That's little s, right? So little s, the yellow is the big S. Well, I guess, what I should have done, right? I should have called this P, the perimeter. The perimeter is big S minus little s. How do I calculate little s? Well, little s is the radius times the central angle. But the central angle is in what? Leave myself room there, did I? I need to multiply by 180 over pi. So I'm going to go up here. So I have 20 pi meters minus, what do I have going on here? Remember, the units cancel out. I'm sorry, the degrees cancel out. This 0 will cancel out with this 0. And then again, I'm going to have a, right, I'm going to have 10 times 8, which is 108 pi over 18 meters. 108 over 18, though, simplifies nicely. 20 pi meters minus 6 pi meters, which is 14 pi meters, which is 14 times 3-ish. And again, if I've pushed it into my calculator right, which I just wrote it down, whoops, no, I'm not ready to do that yet. 14 pi meters. Now I might think I'm done. I might think, oh, I'm so proud of myself. But what did I get? Did I really get the entire perimeter? What did I get? I just got the yellow, right? I got the yellow part. I got the whole circle minus the missing arc. Is that the perimeter of that whole little, right, Pac-Man looking thing? I don't think so. What am I missing? I was also worried about taking off that blue piece, but don't forget the perimeter of the whole shape includes here and here. So the perimeter is equal to 14 pi, which is the circle minus the blue missing arc, but it's also in addition to what? So I have 20 plus 14 pi, and this is where I got my calculator out, and I got approximately 63.98. Okay, kind of cool. Perimeter means what perimeter meant a long time ago, along the outside. It's just before, every time you were going along the outside of everything, it was always straight lines. Now you have a way of calculating length around a curved circle. Well, this is a bummer. All that stuff was supposed to be coming out not at the same time. Boo. So play along with me and pretend you didn't see all of this at first. So now we're going to do angular versus linear speed. Speed is the absolute value of velocity. So velocity can have direction. It can be positive or negative because I can go 50 miles per hour to the right or 50 miles per hour to the left. But for when you're talking about how fast I went, you always talk about positive. So speed is just the absolute value. I'm so thrown off by the fact that I didn't turn my animations on. Sorry, speed is the absolute value of velocity, which just means speed is always positive. So you've dealt with calculating speed before. Speed, or something we're going to call linear relationship, which is then supposed to be the car, right? Think about a car driving, is distance traveled over the time traveled. So for instance, let's say I went 100 miles and it took me 2 hours, right? My speed is 50 miles per hour. Yes? My rate. Well, now I want to talk about spinning. How fast are you spinning? So think about a tether ball, right? If you hit this ball and it spins around, how fast is it spinning? We call that angular velocity. Instead of linear velocity, angular velocity, and the Greek letter we use is omega. But still, you're still talking about, instead of linear velocity is distance traveled over time, the distance we're traveling is radians. And radians is your theta. So how many radians did you travel per time? So again, if I think, for example, of, here's a circle, and let's say I have a ball. This is kind of suspending reality, right? Because my ball is able to go straight up in the air. But let's say my ball is here at pi over 2, and then it takes 3 seconds for my ball to get down here at pi. Took me 3 seconds. My angular velocity is how many radians did I travel? Pi over 2 radians per second. That's my angular velocity. Notice again, you need to be in radians. So that's swell. But what if I want to know how fast the linear velocity? So for example, if I could take this spinning, right, and spread it out straight, what's the linear velocity of a spinning object? Well, linear velocity is still distance over time, right? But how do you calculate distance of a circle? Distance. Well, isn't distance what we were just talking about before? So distance, right? Not the radians, the distance I went is the arc length, right? So, and I have a formula for arc length, don't I? Oh, there comes some animations. So bitter. So, and look at what I'm doing algebraically, or not even algebraically, for elementary school fraction work. I'm taking arc length over time of travel and splitting it up into arc length times 1 over time. Right? That's the same thing. But look what happens when I do that. Arc length, we have a formula for arc length, which is r times theta times 1 over time. Now I'm going to put that denominator back, right? And I'm going to multiply, that's theta over 1, right? Theta times 1 is theta, time times 1 is time. So now I have r times theta over t, But what did we just say theta over t is? Theta over t is what we call angular velocity, which is omega. So this is the formula that we have for the linear velocity, not angular velocity. Linear velocity of a spinning object is the radius times the angular velocity. That's deep, and we're going to spend a couple of days on problems like this, but I want to do a couple of the simpler problems with you where you just have to remember your formulas and your units. So here's your formula. The linear velocity, v, of an object traveling or spinning around a circular path where you have a radius of that circle and the angular velocity omega is the radius times omega, given that omega is measured in radians per time. Bitter. So example 1, find the linear velocity of a particle moving around a circular path with a radius of 3 feet, rotating at 2 radians per second. Remember, radians you don't have to write down, so what is this? Radians are unitless, so I get 6 feet per second out of that. This one, what are they doing here? They're asking for you the angular speed. Who's the angular speed? Good, that's omega. So this time they give me my linear speed, 5 inches per second, is equal to radius of 10 inches times omega. And I'm trying to find omega. So to get omega by itself, five inches per second times 1 over 10 inches. The inches cancel out, and I end up with 5 radians per second. Oh, 5. 5 over 10, you moron. Which equals a half radians per second, or 0.5. Okay? Last problem. Example 3. Find the radius, so they want me to find r, of a circular motion if a particle travels at 2 meters per second. So what is that? That's my linear velocity, right? Makes 10 revolutions per second. I'm not sure quite what to do with that. Well, let me see. If I can't think about what to do, let me at least set things up. Let me go up to my formula, and I'm going to put 2 meters per second is equal to the radius I'm trying to find. And then I don't know quite what to do with this. I mean, it does have to do with revolutions, which has to do something with W. 10 revolutions per second, but I don't want omega can't be in revolutions per second, it's got to be in radians per second. Well, what relationship do you know right? 1 revolution around a circle, your unit circle, is what? 2 pi radians is 1 what? Revolution, right? 2 pi r, but here's my r, right? Here's your r, right? 2 pi times r is 1 trip around the circle. And now look what happens. My revolutions cancel out, and I end up with 2 meters per second is equal to 20 pi radians over what? Times the r I'm trying to find. How do you isolate r then? R is equal to 2 meters per second times 5, that's seconds. Seconds, looks like a 5, over 20 pi. And what happens to your seconds? So I end up with r is equal to 1 over 10 pi, which is approximately, I didn't write that one down. I was looking to see if I wrote it down, but I didn't. Calculator. Good? All right. Like I said, this gets a little, right, a little complicated, but your homework tonight shouldn't be too bad. Right, the simpler problems, especially degrees, minutes, seconds conversions, radians to degrees conversions, special angles, non-special angles, and then a little bit about arc length and this linear and angular velocity. Mostly just playing around with the formula. All right, so I will see you tomorrow. Hope you have a good afternoon, good rest of your day, and I'll leave you with this comic. See you tomorrow.